What if I told you there's something in the universe that can stop time, warp space, and trap even light forever? A region so strange, so powerful that it defies our understanding of physics? Welcome to the world of black holes. They're not just science fiction. Black holes are very real, and they exist all across the universe. In the next 10 minutes, we'll explore what black holes are, how they form, how we detect them, and what mysteries they might still be hiding. A black hole is a place in space where gravity is so strong that nothing, not even light, can escape. That's why it's called a black hole. At the heart of a black hole is something called a singularity, a point where all the matter has been crushed into infinite density. Surrounding that is the event horizon, the invisible boundary where escape becomes impossible. Once something crosses the event horizon, it's gone forever. Time itself behaves strangely near a black hole. To a distant observer, a clock falling into a black hole would appear to slow down as if time were stretching out. In fact, near the event horizon, time can nearly stop relative to someone far away. Black holes are born when massive stars die. During most of a star's life, it balances gravity pulling inward and pressure from nuclear fusion pushing outward. But when the fusion stops, gravity wins. For stars much more massive than our Sun, this collapse creates either a neutron star or, if the star is massive enough, a black hole. There are also other ways black holes might form. Some are born from the collision of dense stars or black holes, and some scientists believe the earliest black holes, known as primordial black holes, could have formed just moments after the Big Bang. There are three main types of black holes. Stellar mass black holes are the most common, formed from the collapse of giant stars. They can be a few to dozens of times the mass of our Sun. Intermediate mass black holes are less understood and harder to detect. They're thought to form when stars or black holes merge in dense star clusters. Supermassive black holes sit at the centers of most galaxies. They can weigh millions or even billions of times more than our Sun. Our own Milky Way has one called Sagittarius A at its center. How these supermassive giants formed is still a mystery. Some may have started as smaller black holes that grew over billions of years. Others may have formed rapidly in the early universe. But we're still piecing that puzzle together. Even though black holes are invisible, we can detect their presence through their effects. When gas or matter gets pulled toward a black hole, it spirals in and heats up, forming a bright glowing accretion disk. This disk can emit powerful X-rays and other radiation, and that light can be seen with space telescopes. We can also observe the way stars move. In the center of our galaxy, astronomers have watched stars whipping around something invisible. The only explanation? A supermassive black hole. Then there's gravitational waves, ripples in space-time caused by massive objects like black holes colliding. In 2015, we detected these waves for the first time, confirming a key prediction of Einstein's theory of general relativity. And in 2019, we got the first ever image of a black hole's shadow. The Event Horizon Telescope captured a glowing ring around the supermassive black hole in the galaxy M87. It was blurry but historic. Let's say hypothetically you fell into a black hole. What would you experience? As you approach the event horizon, gravity would increase dramatically. If the black hole were small, you'd undergo a process called spaghettification. Your body would stretch vertically and compress horizontally like a piece of spaghetti. If it were a supermassive black hole, the gravity near the event horizon would be less extreme, and you might not even notice crossing the boundary until it's too late. Once inside, you'd be pulled inevitably toward the singularity. What happens there, we don't know. The laws of physics as we understand them break down. Some theories suggest the singularity could connect to another universe. Others believe it marks the edge of all known reality. Black holes aren't just fascinating. They're essential to our understanding of the universe. They help shape galaxies. The supermassive black holes at the centers of galaxies might play a key role in star formation and galaxy evolution. They also challenge our understanding of physics. Black holes sit at the intersection of relativity, which governs large-scale space, and quantum mechanics, which governs the tiny world of particles. To understand black holes fully, we'll likely need a theory of quantum gravity, something scientists are still searching for. Studying black holes may eventually lead us to a deeper understanding of time, space, and even the origin of the universe. Black holes are more than just cosmic monsters. They're portals into the unknown. They push the boundaries of science and imagination, and they remind us how much we still have to learn. In the darkness of a black hole lies the brightest frontier in science. Thanks for joining this journey into one of the universe's deepest mysteries.